Yeah, all right. I'm in Adriana would know. I'm in Parish's snowboarding. So have you guys read this?
Yeah. No.
Hmm?
What?
Oh, you didn't see the chat. Okay, no, it's okay. Hannah, does this make sense?
Kind of.
I know, okay. So this is another way of completing the square. So normally we wish to solve something like this, right?
Yeah.
Assume that there's no coefficient in front of x, we're solving something like this. First of all, we ignore this term, we just work with this, okay? And here, rather than like what I've taught you guys is to like think about it as being a square, and there's an extra term you want to offset that term, right? Here it gives you that term straight away. It tells you that the term is b over 2 squared, okay? So we just put that term on both sides straight away. It tells you it's this term, okay? The motive behind this is the same, so that you can factorize this, and then this extra term is the extra bit. If you put it in the left, it's minus b over 2 squared. It's the same as what we have before. So you have this extra term, the left-hand side actually becomes a perfect square. This is your x squared, this is the other part squared, this is your 2bx, right? 2b over 2x. So that's the middle term. So this part pretty much becomes this part, and then you have completed your square. Right? Completing the square pretty much when you complete the square, it's x plus something inside the square. And the thing to check here is that x only appears in the equation once, okay? That's what makes the equation much easier to solve, okay? All right, just a little challenging question for you guys. So let's say right now, assume you know A, B, C, assume you know B and C, right? Assume you know B and C here. Let's just say maybe C is 20, B is like 15 or anything like that, but treat it as a number. But like, let's say you know it, but treat it as a variable, right? How would you solve x in this case? I'll give you a hint. You can solve x by just simply rearranging. Okay, you can just simply solve x by rearranging. For example, when we started learning algebras, x plus 5 equals 10. How do you solve x? You subtract 5 to both sides, right? So that's what we call rearranging. So you can solve x here by simply rearranging. First step will be square rooting both sides. It will be plus or minus. Okay, let me draw something here. Red pen. All right, cool. So the first step here will be, will be square rooting both sides, but we know that square rooting the right involves a plus or minus. Okay. Oh, why am I? I just said it and I forgot to write it. You know what? This is ugly here. We're just gonna write it here. So plus or minus square root c plus b over 2 squared. Okay. That's the first step. And then, sorry, my writing is going to be a bit bad today because I'm using my mouse once again. Because I'm outside and I forgot to bring the writing pad, which is kind of painful. All right, so we square root both sides. And now, how do we solve x, anyone?
Do we minus the b from, like, do we bring the b over to the right-hand side?
Yes, and then we will only have x left, okay? So here, what do we have? We have b over 2 plus or minus square root
Wait, why is it not negative b over 2?
you're right, it should be negative b over 2. C plus, let's see, b over 2 squared. All right, so here, what are we solving? We're solving x x squared plus bx plus c, right? So if we know the value of b and c, this will be our solution, right? So the difference between this and the general form is that we normally have an ax squared plus bx plus c, right?
Yeah.
Equals 0. And we know the solution to this, which is the quadratic formula, yes?
Yeah.
So what is the quadratic formula? Anyone can remember? Off your on top of your head, anyone?
Is it plus minus b square a times b times, wait, no, I can't remember.
Okay, negative b plus or minus square root b squared minus 4ac.
Oh,
So this
yeah.
part is easy to remember. B squared minus 4ac is like the discriminant. You deal with it so much that you remember it. And you also you can remember like this, okay? I think about it like this. You know there's a b term, there's a b squared term. There's no point having a negative sign instead of in front of b squared. So it's negative b plus or minus the positive b squared, okay? This is a way to remember. I was like, there's no point to have a negative sign in front of the b that's being squared because it just cancels out. All right, so we can try substitute a in front of it. Oh, let's try something interesting. Can we make the screen? Oh my God, I'm lagging. Okay. Oh, what? Can we make the screen? Ooh, I believe we can. All right, so let's try something here. We know this is the formula for the general case, right? But right now here we have a equals 0. Yes?
Yeah.
Right? Oh my God, today's writing is going to be a little bit of pain, okay, a lot of pain. I'm just gonna be quick. All right, so if we substitute a equals 0, do we get the same equation? We should get the same equation, otherwise this is wrong, okay? So if we substitute a equals 0, sub a equals 0, we get negative b over 2. Okay, that looks right. Plus or minus this square root thing over 2, right? This square root thing over 2. Okay? So here, the first term is the same. Is the second term the same? Can anyone tell me?
Wait, what? Like what term?
So negative b over 2 is the same, and then plus or minus the second term. Is the second term the same?
No,
Why is it not the same?
because I don't know.
The only difference here, because dividing by 2 makes it put it in the square roots divided by 4. Does that make sense?
Oh, yeah.
Okay. So you get b squared over 4, and then you get b squared over 4 minus 4ac over 4. So in the end, you get this is fine. Wait, this is fine, but this should be negative c instead. So this is problematic. This is fine. Okay. Because you get b squared divided by 4, that is b over 2 squared. And then the 4 cancels out with the bottom, okay? So
Yeah.
I can write out one extra line. This is negative b over 2. I think I can have space on the right. Oh, I do have space on the right. That's great. Wow, my Word document is lagging so much. I don't know why. Maybe I think if I turn off autosave, it'll be better because OneDrive is saving it all the time. All right, so now all right, I'm drawing more space. Okay, so now if we try to expand this, the first term is the same. And the second term, you divide it by 4, right? If we bring it into the square root, yes? B squared over 4. B squared minus 4AC over 4, right? And we can maybe have one more line. Plus or minus. Guys, I think I'm getting my mouse writing skill back. So B squared divided by 4 is simply B over 2, whole thing squared, right? And then minus AC, okay? Oh, A is 1, sorry. A should be 1, so we should always have A gone, okay? Any questions? So when A is 1, this is what our quadratic formula becomes. Any questions, guys?
Oh, so A subs into 1 or like,
Yes, we put A. Sorry, no. Sorry. When A equals 0. Oh wait, sorry. When A equals 1, I wrote a mistake here. Yeah, because it's x squared, right? It's x squared, so it's 1x squared. Yeah,
uh-huh.
I wrote a mistake, but yeah, does that make sense?
Yeah.
Hannah?
Yeah.
Okay. So, oops. All right, cool. So the difference here is that we got a negative c here, but a positive c here, and the reason is because we followed this, right? Oh, wait, why is it not drawing anything? We follow this. And this has a positive c on the right, right? If we are moving the c to the right, it should actually be negative c. So we actually did this, we solved this instead. So that's why it's slightly different, because we started with positive c on the right. Does it make sense? So technically, if we start here, we should have minus c on the right, okay? That's why it's not the same. Does that make sense?
So they're two different things.
No, it's just that we, okay. Wait, let me go up a bit. So you know the first line, how it said, write the equation in the form of this? If we want to keep the c the same, if we want to keep these two equations the same thing, yes, you said it's different thing, but if we want to make them the same thing, we should pretty much write this instead, rather than having a positive on the right. Then yes, they are different. Not completely different, just differ by the sign of the c. The sign of c differs. Okay, make sense?
I think so.
Okay, so it doesn't have to be like fully make sense, because this equation, we're just trying to prove if it's the same, and we realized we actually solved this rather than this, which is why C is different. And the only difference between those two is that C, when you move it to the right, it should be negative, but they didn't put the negative sign in. Okay. Not much is happening here. It's just yeah, a little revision on completing the square. And today we were gonna do some advanced quadratics. Okay, so continuing from last time, and then we'll talk about transformations a bit later. Right now, let's try to do some factorizations. Okay. So again, I'll remind you guys, there are 3 ways of solving a quadratics. The first one is to use factorization, but that's the least powerful way because sometimes a quadratics cannot be factorized. Okay. And then the other 2 ways are related to each other. So you got a quadratic formula, which is derived from the third way, which is what we just did, completing the square. Okay, any questions? If not, do question 1. Ask me if there's any questions, okay?
So we just apply that formula that we just did.
Oh no, you don't apply formula, you factorize.
Oh, okay.
We've done this before.
Well, wait, so
You
this
can use
isn't.
formula works, but here the point is not to use formula. Okay. Make sense?
Yeah.
So I believe both of you should be comfortable with everything in question 1. When we get to question 2, it's gonna be slightly more tricky. But I mean practice, right? So yeah, do all of question 1. If there's any questions, ask me. Actually, I'll be back in 1 minute. I don't know where my phone is at. Okay. Oh, by the way, I'm back, guys. If there's any questions, ask me. All right. All right. How's everyone doing? Which question are you guys up to?
I'm on 5.
Okay.
Oh, I'm on 3.
Okay. So if you're unsure about factorize, double check, just factorize, right? And then just expand it and check it. Hannah, tell me when you finish F, okay?
Are we meant to do 1 and 2 or
Yes, yes. But tell me when you finish one. I'll check answers.
oh
As you can probably tell, I don't even have a table with me. I'm literally lying on a bed. But I don't want to cancel. I think last time, why did I cancel? Oh, last time, the only time I canceled was because I was at a place where there's no internet. And then when I planned the trip, I don't know, I was like, I forgot it's Sunday. And then, yeah, I planned the trip like long time ago. If it's one-to-one, times is like, I guess, more flexible. But like, if it's group lesson, I'm never gonna cancel. All right, Hannah, how are you doing?
I did 6, but I can't get 5.
Oh, okay. I'll just remind you the few ways you should like how you do it. So first of all, look for the factors of the last number because the last number is the product of the two things, right? And the sign is important. Negative sign indicates it's negative times positive. So 42, there's not many factors of 42, and you want to find the pair such that the difference or the sum, right? The sum, but like the difference if it's a minus and a plus, right? Such that the sum gives you plus x or plus 1. Okay? All right, tell me when you guys finish the first 6 and I'll go through the answers.
I'm done.
All right. I'll wait for Hannah, wait for you for 1 minute, okay?
I'm done as well.
Mm. All right, anyone volunteer for A?
I got x equals 1 and x equals -3. Wait.
Tell me the factorization first. I haven't done it, so.
Oh no, x equals 1 and x equals 3.
Yeah, tell me the factorization first. What do you get for the factorization?
Good. Bracket x minus 1, close bracket, and then like bracket x minus 3.
Sure. What did you get for solution?
Yeah. And then what?
What did you get for the solution?
X minus 1 times x minus 3 equals 0.
Yeah, that's the factorization and the solution. So what does x equal to?
Oh, x equals 1 and x equals 3.
Yeah, so this is called the solution. Okay, this is like what your step after you factorize. Okay.
Yeah.
So what does the solution mean? I think Hannah, I think you know this, but Adriana, I'll remind you. So when you plot this graph, this looks something like this. You are solving for the x-intercept, right? Because on the right-hand side, this is 0. So this is, you can treat this as y equals 0, okay? So this is y equals 0. That means it's the x-intercept. X-intercept is at 1 and 3. So it's like, boom, it's like this, okay? This is your graph. And what you just solved is these 2 points. Wait, I'm lagging. So what you just solved is, so the graph looks like this, and what you just solved is the x-intercept, or we call the root, the solution of the graph, the root of the graph, the x-intercept. X-intercept is actually least used. We call the root or solution the most often, okay? All of them means one thing, the 1 and the 3, where it intersects the x, okay? Does that make sense, Adriana?
Yeah.
Hannah, do you know this?
Mm-hmm.
Okay, cool. Hannah, B.
Bracket x minus 5 bracket and then bracket x plus 4.
Okay, sounds right. What's the root?
X equals 5 and x equals -4.
Okay. Adriana, did you get the same thing?
Yeah.
Okay, that's good. What about C?
I got bracket x minus 6 bracket times bracket x minus 2, which equals x equals 6 and x equals 2.
Sorry, say that again. Just
And
just the line, just that line, just the factorization.
x minus 6 times x minus 2.
Adriana, not Adriana. Hannah, did you get the same thing?
Yes.
Okay. D, Hannah.
I got x equals -11.
What's the factorization here?
X um is it just x and then plus 11 for both of them?
You can try. What happens with plus 11? If you try to expand this, what do you get? You get x squared plus 1 to 1 plus 22x, right? So always check your
It's
answers.
one of them is 0 and one of them is 120. Actually, I have no clue.
Okay, so here this is slightly harder one because you don't get a middle term. But you could think about like why you don't get a middle term because the middle term is 0. Okay, it's pretty much x squared plus 0x minus 121. So you want to find the factor that gives you 0, and that is plus 11 and minus 11. Does this make sense?
Mm-hmm.
This is also related to the formula. We have this formula. I made Adriana copy it 20 times. Adriana, did you copy it?
Yeah.
Have you done it? You said haven't sent a photo to me.
Oh,
So
I
what does
must
this equal to?
the photo.
What does this equal to?
Um, a squared plus 2ab plus
Okay, did you copy your formula?
yeah.
There's 3 of them. This is one of them, but you didn't get it right.
Oh, hold up.
Did you really copy them?
I did them like a while ago, and then I haven't been doing them
Oh,
ever.
you need to send me the photo. If you can't find the photo, you need to copy it again. It's only 3 formula 20 times. That's 60 formulas. It takes like 10 seconds each. It takes like 5 minutes. If you can't find it, copy it
I
again.
didn't
Spend
think I
another 5
needed to
minutes.
send you a photo.
No, I said that. I definitely said it. I need in the photo. I need to see you
A
copy it 20
squared
times.
minus b squared.
Especially you forgot about this one.
Whoops.
Okay, yeah, Hannah, do you know this?
Yeah.
Okay. All right. Yes, that's the solution. So, oh, that's the factorization. And the solution is in this case the solution is easy. Solution is just plus or minus hmm, plus or minus 11. Okay. Another way to do this, if you look at D, so alternatively you can do something. If you want to just solve it, you can do something like this. So x squared equals plus or minus square root 121, which is plus or minus 11. Make sense to everybody?
Yeah.
Mm-hmm.
Cool. All right, whose turn is it? Someone do E.
I got x minus 6 times x plus 7, and that
Mhm.
gives x equals 6 and x equals negative 7.
Okay, Adriana, always keep in mind that you are looking at the quadratics. Don't like try to systemize too. Don't try to like what's the word? Do everything too systematically. Okay. So you got to think about factorize is a step of rearranging it so you can solve it, and what you are solving is what we call the root. So if we are plotting this graph, this is the x-intercept. Okay. Always keep that in mind rather than like systematically do everything and then you might forget what you are doing. You know what I mean?
Wait,
But yes,
what?
that is correct. Huh?
Um, Wait, what do you mean?
So okay, so remember the formulas. The formulas I made you copy. Okay, there are two sides to it. One side is like if you remember it by the definition, you probably don't have to copy it 20 times to remember it forever, right? If you just remember using factorize,
Oh, okay.
right? Just expand it like times, right? That's the intuition side. Okay, the hardcore side is what we are doing right now. It's like copying it 20 times or like do a lot of questions, right? This is rather ineffective, but you still gotta have some of those practices. And I was saying like if you do a lot of those questions, your brain might get like frozen or like too stubborn to know what you're actually doing. You're just following a set of steps rather than what you are actually doing. So I was like, the first step, you are rearranging. You are bringing it into factorized brackets. You can also expand it back, right? And the second step is to solve it. And as I said, maybe the intuition behind it is because it's already bracket times bracket. You know, if one bracket is 0, then then the whole thing is 0, so the equation is satisfied. So when you are doing this, always refer back to the intuition, the logics behind the steps, so you can remember it better.
Oh, okay.
To put it in simple terms, maybe use the formulas you copied as reference. So when you're copying the formula, just think about why those formulas works rather than just blindly copying it line by line. Okay.
Okay.
All right. Hannah, what did you get for the last one?
Um, x minus 4 times x minus 4.
Nice. What's the solution?
x equals 4.
Okay, is that the only solution?
Well, isn't it just 4 and 4? So it's 4.
Yes, it is the only solution. So be confident, okay? Yes, the last one, why is the only solution? If we think about the graph, it looks something like this. At 4, it looks something like this. Okay, this is a 4, okay? And this is probably 16. That's for question F, okay? Any questions?
No.
Cool. Okay, how do I group this? All right, now, do you guys think you can do question 1? Sorry, no, question 2, or do you guys want me to like do an example first?
Can you do an example?
Okay, sure. All right, so first of all, everything is still the same. You're trying to bring it into 2 brackets. Okay, let's see if there's an example. Yeah, you can't really simplify. Oh, for this one, oh, never mind. No, yeah. Okay, let's try to do A. Okay, so you got 2x squared plus x minus 3. So rather than having x and x, what you have right now is a 2x and x. That's the only way you get 2x, assuming you don't have decimals, right? If the question asks you to factorize, it's probably never going to have decimals. 2x and 2. And what does 1 and 3 give you? 1 and 3 essentially gives you, sorry, not, negative 3 gives you 1 times 3 only, right? But with a negative sign. So it's either negative 1 times 3 or it's a negative 3 times 1, okay? And this is the 2 possibilities. And you want to match it with 2x and 2. So there are 4 ways of matching it. Because, for example, if you know the first one, the negative 1 can either go with 2x or it can go with 2. So theoretically, you have to try out every single possibility. But by looking at the middle number, which is plus x, right? You could think, okay, oh, sorry, wait. This should be x, not 2. Did anyone saw that? So yeah, by looking at the middle number, you can roughly rule out some what is it? Some combinations. So there's 4 of them, but knowing that the middle one is a plus 1, we can simplify stuff a little bit. So how do we get a plus 1? If we have 2x times 3 and x times minus 1, that is like plus 5, right? So I'm like really quickly trying out every combination and see if I get minus 1. So technically, what I tell you guys this as well. I was like, if you're not sure, just put numbers in and expand it, see what you get. Literally, just there's 4 possibilities, just test it out, right? So if we have like 3 over here and 1 over here, it doesn't matter if it's plus or minus, right? The 2x times 3 is going to be too big. It's going to be a positive 5 or a negative 5. So it's not this. So we're definitely having the 3 in the front, so the 3 doesn't get multiplied by 2x. So the 3 gets multiplied by x. And the 1 gets multiplied by 2x. So it multiplies like this. Boom. Oh. So for the x term, it multiplies like this. All right, now how do we get positive 1? We get positive 1, so we get 2x and x here. So we want the 3 times x to be positive. So we want positive 3 times positive x, okay? And then and we want a minus 2, okay? So it's a minus 1. So now if we try to expand this, we can see that this actually equals to what we have. Does this make sense? Yeah, so it's pretty much guess and checking, but like with a lot of experience. So like when I'm trying to put the numbers in, it literally runs in my head. It'd be like, okay, 2x times that, x times that, that's not negative 1, pass, okay? This is very hard. This is very hard because it's not unique. You can get 4x and x or 2x, 2x. That's very hard. So don't do C right now. This is very hard. This is very hard. So do B first, and then actually, yeah, do B first. Once you are certain that your B is correct, do C. Okay. By the way, figure out the solution for A as well. I'm I'm gonna let you guys figure out a solution for A. It's the same thing. Bracket, bracket equals 0, and then solve one of the bracket. And you still, yeah, each bracket gives you one solution. Any questions?
No.
All right, good luck. Do A and B first. I'll be back 30 seconds to 1 minute. Grabbing some water. All right, how's everyone doing?
I'm on 4.
Oh, nice. Okay. Rihanna?
I'm on 3.
Okay. So both of you got A and B. Okay. All right. Yeah. In that case, if you're on, okay, Adriana, tell me when you finish 3, because 3 is a little bit hard. And yeah, if you finish everything, both of you, if you finish everything, to tell me. Okay. In the meantime, I'm just gonna be here. Okay. Not gonna lie, lying on the bed is kind of inappropriate, but I don't have a chair. I don't have a table. I'm gonna turn off my camera. I think I'll give you guys 5 to 10, at most 10 minutes for this, and then we'll go through the answers.
Oh, I finished 3.
Okay. Uh, Hannah, which one you on?
I'm still stuck on 4.
Okay, let's do first three first. See if you guys got the right answer. Oh my God, I accidentally dropped my mouse.
Oh, by the way, I did it a different way. Like,
As long as you can get the factorization, it's fine.
okay.
Hannah, actually, you know what? Adriana, what did you get for the solution of the first one?
Negative x equals negative 3 over 2 and x
Okay,
1
and what?
and x equals 1.
Hannah, did you get the same?
Yeah.
All right. Hannah, second one. B, what did you get?
X equals
Yep.
negative 4 over 3.
For the factorization first.
Oh, right.
I don't know. I don't know the factorization, so yeah, I can't tell the root as well.
3x plus 4 times x minus 3.
Adriana, did you get the same?
Yeah. Oh, I think I did C wrong. Let me just look at it again.
And then X, what, 3?
Minus.
Adriana, did you get the same?
I got x plus 3.
Okay, it's definitely not minus because the plus minus sign in the 12 tells us it's a plus minus. Okay, so this minus sign here tells us it's a plus minus.
Oh, I think I meant plus.
Okay, so sure. All right, let me check if it's correct. 3x is fine, minus 12 is fine. 3, that's plus 9 minus 4. Okay, that is correct. What did you get for the roots?
X equals negative 4 over 3 and x equals negative 3.
Okay, that's correct. Nice, good job, good job, good job, good job. For C, Adriana, for C.
Well, I I got x equals negative 2 or x equals negative 3 over 4.
What's the factorization?
I did 4x plus 3 times x plus 2.
All right, so 4x plus 3 times x plus 2.
Yeah.
Okay, 4x is definitely correct. 6 is definitely correct. This is 8. This is 3. Oh, nice. 11. Hannah, did you get the same thing?
Yep.
Amazing, amazing. I'm gonna sneeze. Okay, I lost the sneeze. That's unfortunate. Okay, cool. What's the root again, Adriana?
Uh, x equals negative 2 and x equals negative 3 over 4.
Okay, nice, nice, nice. Good job, everyone. All right, keep going. Finish D, E, and F. The first three questions are correct. So, yeah. All right, how's everyone doing?
I don't get D.
Okay, you can move on. Move on. Just move on to E.
Yeah,
D,
I got the other
D
one.
is you can use the same formula. A plus B, A minus B. You can use the same formula. Did you get it for D?
No.
So if I tell you it's already A squared minus B squared, right? Your A and B can be anything, so just find your A and B.
Yeah, but I'm just confused with the 9x.
How do you, okay, what is, if I say something squared gives you 9x squared, what is that something?
30.
Not just 3 and something else. So 3 squared
Oh,
gives you 9. What about x squared?
what, 3 and 4? What?
No, so the whole thing is 9x squared, right?
Yeah,
Something squared gives you 9x squared. What is that something?
3x.
Yes, that's it.
Yeah, that's what I wrote, but I don't know.
So yeah, so I told you this is a squared minus b squared. Yes, as a hint. So if this is a squared minus b squared, your a is 3x. Your b is what? What's square root of 49? 7, right? So using the formula for question D, 1D, use that formula, you get the factorization straight away. And you can also check if you want. Does that make sense? I'll just give you the answer if you say no.
Wait, is it plus and minus?
Yes.
Oh, yeah, I got it.
Okay. Adriana, which one you up to?
I'm done.
Oh, sweet. Uh, okay, let's see. We'll take like a 2-minute break and then we'll check the answer, okay? And then we'll have maybe a longer break. All right, Hannah, how are you doing?
Oh, I thought we were on a break.
Oh, no, sorry. No, I told Adriana to take like a 2-minute break and then we'll go through the answers.
Oh, I was already done.
Oh, wait. Oh,
I
you didn't tell
already
me.
finished them, and I
I thought
went
you.
back to D because I didn't know it.
Oh, okay. Adriana, are you here?
Yeah.
Yeah, I was like, okay, I thought you didn't finish. Oh, in that case, we'll just go through the answers. D, anyone? Okay, Adriana, what'd you get for D?
I got 3x plus 7 times 3x minus 7.
Yep, Hannah, did you get the same thing?
Mm-hmm.
So using the formula, okay? What's the solutions?
Oh, x equals negative 7 over 3 and x equals 7 over 3.
Plus or minus 7/3, okay?
Oh, yeah.
Once again, you can use what I told you before. So if you see something like this, see, x only appears here once. So technically, we are already completed the square, okay? So if we have, so technically, we already completed the square. So here we have 9x squared equals 49. So your x squared equals, you got to divide by 9, okay? 49 over 9. And then we square root it. X equals, what? So now we square root both sides, right? So x equals plus or minus, because it's x squared equals that, so x equals plus or minus, okay? Plus or minus, yeah, I'm not gonna write the square root. I'm just gonna write 7/3 straight away. All right. Any questions about this one? Any questions about this question? If not, we'll move on.
No.
All right, cool. I like how I can group this and just make it super small. All right. For E, what did you guys get? Let's see. Who would I pick? Hannah.
E, I got 2x minus 1 times 2x minus 7.
-1 and -7. Okay, Adriana, did you get the same thing?
Yeah.
Okay, Adriana, what did you get for the root?
X equals 7 over 2 and x equals 1 over 2.
Hannah, did you get the same thing?
Yes.
All right, F. Adriana.
I got 4x plus 5 times 3x minus 1.
All right, so 4x plus 5 times 3x minus 1. Let me
Yeah.
double check.
Maybe it's wrong. I don't know.
So 5 is correct, 12x is correct. Let's see if 11 is correct. We get 5 times 3, that is 15. 4x times -1, that is -4. What is 15 minus 4, Adriana?
11.
So is it correct?
Yeah.
Are you sure?
No. Wait, I don't know.
No, I'm just joking. It is correct.
Making me all like anxious.
No, I'm just kidding. It's correct. Did you
Oh,
double check? Did you double check?
yeah, I did.
Yeah, so it should be correct. Okay. I'm just gonna ignore the roots for this. Actually, you know what? Hannah, what did you get for the roots?
I got 1 over 3 and negative 5 over 4.
All right, looks right. Okay. Good job, guys. Do you guys want to break now, or do you guys want to break later?
Now?
Okay. All right, we'll have a 5-minute break, maybe 5:07, 5:08. Okay.
Yeah.
And then when we come back, we'll do. Oh, before we go to the break. So when you come back, do these questions, okay? And yeah, in case I'm back late, or if you want to start early, do these questions, and then it's pretty much the same, except for you got to rearrange these. You move it to the left, okay?
Yeah.
All right. Okay. Yeah. Yeah. See you guys later. Yo, guys, I'm here by the way. If you have any questions, ask me anytime, okay? Otherwise, we'll just do question one. All right, are you guys back?
Yeah.
All right, yeah, start with the questions, okay?
Okay.
If there's any questions, ask me. All right, Adriana, which one you up to?
B.
Hannah?
D.
Okay. It's pretty much the same thing. For D, there's a little trick you can do. Okay, you don't have to expand it. You can. All right, for C, I'm not too sure. For D, you don't have to expand it
What?
because it already have x plus 5 factorized for you. So just treat x plus 5 as a thing and factorize the other one, if that makes sense. Okay. So for D, you don't have to expand. Okay. If you expand, it's a little bit too much work.
Wait, I don't understand what you mean. Treat it as the other one.
Okay, so x plus 5, treat it as, okay, just replace it with another letter. Let's say y. Okay. And you factorize y out. Okay. Factorize y out and then see what you get. And then you can put x plus 5 back in, replace the y, and you will be factorized. So do not expand x plus 5. Just treat x plus 5 as a whole thing and do the question. Okay? Try it. Give it a try first. If it doesn't work, I'll tell you the answer.
What? But doesn't I just got 3x equals negative x plus 5 over x plus 5. Well,
3x equals negative.
I don't understand what you mean.
Sorry, what did you get? 3x equals negative x plus 5.
Yeah.
Say what you got on the equation again.
3x equals, well, I substituted the thing for y. So I just did 3x equals negative y over y.
Okay, so first of all, y is a variable, right? You divide by y, sure, algebraically it works. But essentially what you're doing, whenever you're dividing a equation with something including the variable, you kind of changing the solutions. Okay. So if I do this, all right, if I say 1 equals x equals 1, right? This is the only solution to this. But now, if I say, okay, let's say 1 times x plus 3 equals x times x plus 3. Yeah, sure, you can just be like, boom, boom, I don't want this anymore. Okay? But right now, what if you substitute x equal negative 3 here? So x equal negative 3 is a solution for this because this goes to 0, this goes to 0, right? Hannah, yes?
Yeah.
But if you don't have this, it simply becomes this, and you got rid of a possible solution. Okay. So you never divide like x something. Okay. If the fraction already exists, you can divide top and bottom of the fraction by whatever x, but you never divide like that. Okay. So dividing is very dangerous, and so is multiplying. When you multiply or dividing x, okay. So notice how when we solve quadratics, we never multiply or divide x whatever. That's the reason. It changes the solution. All right, so here I'll just tell you the answer. Adriana, did you get this?
I haven't done D yet.
All right, both of you listen up. I'll just tell you guys how to do D. So since we see this is the common term, right? What we want to do is we want to move everything to the left first, okay? So here we're moving to the left. We're not dividing, okay? So it becomes plus x plus 5, right?
Oh, is it just 3x plus 1 and then x times x plus
Yes. If you treat x plus 5 as the whole thing, it would be 3x plus 1. and then x plus 5.
Oh, okay.
Hannah, does this make sense?
No.
Okay. Oh, why am I using Zoom to write? I should have, oh my god, I should have used Word document to write. Alright, anyway, old habits. Yeah, let's use this right. Alright, so we got this and this. So let's substitute y. We get what? Let's say y equals x plus 5, okay? Or y could be confusing. Let's use another letter. Let's just say k, okay? K, good letter. Or p. You know what? Let's use p. I like p better. K stands for constant. P is normally a variable or a function or something like that. Alright, so now we have 3xp equals minus p, yes?
Mm-hmm.
And we want to factorize. It's asking us to solve it by factorizing. So why don't we just factorize p out? So move everything to the left. Oops. So plus p equals 0. Factorize p out, 3x plus 1, bracket p equals 0, right? Hannah, yes?
No,
Why not?
because I don't understand it.
From here to here, what's wrong?
Where did you get 1 from?
Ah, 3x times p plus 1 times p.
All right.
Okay, yes? This is good?
Mm,
Alright, and then remember what p is. P is nothing but x plus 5, okay? So we just replace p back. Like we never really need the p in the first place if you could if your algebra is good enough so you can see this straight away. But if you can't see this straight away, replace it with p. You just know this is p, right? So now this is factorized. Okay? Yes?
I still don't get it.
Which part you don't get? Which line? Okay. Math, you go from line 1 to line 2, line 2 to line 3. There's one line that you don't get. Okay? Is there any line here that you don't get? Just tell me which line.
Well, how do you get from the second to the no third to the fourth, and then no wait, hold on. 1, 2. The second to last, the last one.
Okay, so we know our p, we used p to represent x plus 5, right?
Yeah.
We just used it to represent x plus 5. This doesn't even mean anything. It just means x plus 5. I could literally just not use p, but keep having x plus 5. But I used p, so it looks clearer for you. So we factorize. We take p out. So we take x plus 5 out. And then we have 3x plus 1. Okay? And the last step, we just replace p back to what it was before, which is x plus 5.
And so is that the answer?
You have already factorized it. This is the same thing you get if you expand everything and move it to the left and factorize. This is the same thing you get. We just used a very clever way to do it. If you expand everything, move it to the left and factorize, you get the same thing.
So this is the answer.
It's asking for the solution. Yes, that's already factorized, and the next one will be the solution. Yes.
Michael,
Yeah.
can you explain? I finished, but like I don't understand B. I don't know.
Let me go up a bit. B. Hannah, did you do B?
Yes.
Okay, explain to Adriana how you did B.
I just moved the right side to the left side. Like I did 2x squared plus x squared and then negative 3x minus 2x. And then I got the equation from there.
Adriana, respond.
Well, I don't understand how the equation works. Because I did that, but I just don't get from 3x minus 5x minus 8. I don't get what to sub in. Those
Oh, no, you don't sub in anything. This is a special way. This is a special way to factorize. You're doing the same thing as previous question. See what's asking. It says solve by factorization. You're doing the same thing as before.
Yeah, I know, but I did I can't find the equal numbers between
Oh,
5.
so you can't factorize it. All right, Hannah, how did you factorize that?
I just took the factors of 8 and I got 2 and 4 or 1 and 8. And then
Okay.
I did what?
I'm just writing it out for you.
And then I looked at which one times 3 would get me to negative 5. And it was 1 and 8. Because if you do 3 times 1, it's 3. And then 8 minus 3 is 5.
Oh, okay. Also, could I go to the bathroom?
Yeah, sure. Good explanation. That was good. What's the science for this?
I got 3x minus 8 and x plus 1.
Nice, that's correct. Great. Well, what is the solution?
X equals negative 1 or 8 over 3.
Nice. All right. In the meantime, try to finish everything else. Okay. For
Yeah.
D, if you really don't get it, you can try move everything to the left and expand, and you get the same thing. Or you know what? Maybe okay. For D, Hannah. For D, you do this. Just expand this. Expand this. See what you get. Expand it, and then you're gonna get y is that. Okay, Hannah. Don't expand x plus 5. So don't expand x plus 5. Just expand 3x plus 1. Okay? Do you get what I mean? So treat x plus 5 as a whole thing. Just expand the first bracket, not the second one. Okay? So pretty much I'm asking you to expand this. Okay?
How do I what?
There's a bracket there. You want to expand that bracket.
So 3x times x plus 5 and then 1 times x plus 5.
Yeah, that's the same thing as what we have above, right? Why can't I scroll up? Sorry. That's the same thing as what we have above, right?
Michael, I'm back. What are we doing?
We're finishing off the questions.
2 as well.
Oh, sorry. I need to scrub a bit more. Yeah, do E,
Oh,
F.
there's E and F.
Yeah. Hannah, did you get D?
Yeah.
Okay. Yeah, in that case, we can move on to EF. Okay, 2 is a very interesting question. We can have a look at 2. It's a good application of functions and quadratics altogether. And for the last 30 minutes, we'll be doing completing the squares. Today is a little bit like very hardcore, but I think the result is worth it. There's a lot of algebra practice for you guys, and you guys never really have to worry about quadratics and algebra again, which is good. Okay, so the P here, the D, question D, I used like a very algebra way to solve it. And that's yeah, that's helpful. All right, how's everyone doing?
I think I finished.
Okay, Adriana?
I'm still doing it.
Okay. Adriana, are you on E or F?
I'm on E.
Okay, tell me when you finish E and then we'll go through everything, okay?
Mhm.
Hannah, in the meantime, you can try double checking your answer. You can substitute X in or just simply expand to check if you got the correct expansion, okay? If you're already sure with everything, have a look at question 2, okay?
Okay, I'm done.
All right, we haven't checked question A and C. So Hannah, What did you get for A?
For A, I got x minus 7 times x plus 4.
So we rearrange x squared minus 3x minus 20 plus 8 minus 28 equals 0, and you get x minus 7, x plus 4. Looks about right. Okay. Yeah, I'm gonna skip A because that's pretty easy. Adriana, did you get the same answer?
Yeah.
Cool, cool, cool. Okay. What about C? Anyone?
I
Anyone?
got x equals 6 and x equals 4.
Okay, honestly, I have no idea. That looks so complicated. Let's see. Let's have a look. Mm, First of all, what I see is okay. This is x squared. This is x plus 5, x minus 5. Okay. On the right hand side, is it possible that we kind of save some effort by preserving one of the factors? So in other words, can we get a x plus 5 or x minus 5 out of this? Because that's what make this up. Oh shit, sorry. No, it's a plus 5. Sorry, sorry, sorry. No, 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 never mind. It's a plus 5. There's no factors that you can use. Okay, in that case, we just expand everything. Okay. So 4x squared plus 20 minus 3x squared minus 10x plus 4 equals 0. The good thing is we have x squared straight away. Minus 10x and then plus 24. So was that Adriana or Hannah? What's the answer again?
I got x equals 6 and x equals oh, x equals 6 and x equals 4, but like x minus 6 times x minus 4.
All right, Hannah, did you get the same?
Yes.
Okay, sweet. That's correct. I'm just not gonna write a solution. Can't be bothered. Okay, and 0. Amazing. The 0 is outside my group. Interesting. Wait. Group. All right, let's have a look at question E. What do you guys get for E?
I got 3x plus 4 times x minus 3.
Okay, so sorry, say that again. Wait, I need to here.
3x plus 4 times x minus 3.
So here, again, we can't use x plus 2 and x minus 2, anything like that, okay? But what we can do is we can actually, we can expand that. We get x squared, so 3x squared, and minus 4, so it's minus 12. So 3x squared, minus 5, minus 12. Here we have 3x squared minus 12, we get minus 5. 3 minus, 9 plus 4, looks about right. Adriana, did you get the same?
Yeah.
Okay, cool. Good job, good job. Okay, so F. Oh, F is similar. Okay, so you just want to multiply x across. Okay, Adriana, you multiply x across, you get x squared plus 8x, and move the minus 15 to the left. And then becomes a plus 15, but plus 15 is 3 and 5, right? Plus 3 plus 5. Hannah, is that what you got?
Yeah.
Okay, so the answer for this last one would be x plus 3. I can't even bother write the working. X plus 5, okay? So the key is to multiply this across. Multiply across, okay? I'm blocking the next question. Multiply this across. Okay, cool. This is question B, C, D. All right, any questions before we move on to question 2?
No.
Let's see if we really want to do this. Yeah, why not? Both of you have done functions, so let's have a look at this. So we define some quadratics functions. Okay, h and f are quadratics. G is just a random linear function. And it wants to show that if we put g inside f, we get 4x plus 4x squared plus 4x minus 1. So yeah, guys, let's show that and see if we get the answer. Adriana, do you know what you're doing?
Kind of.
So f, a little og, this is f bracket g bracket x, okay? I think,
I
I
thought,
think
is that not times?
that's not times. We did this lastly, but I don't know if you got up to that question. If you got up to that bit.
Wait, Michael, can I go to the bathroom, please?
Yeah, sure. All right, Adriana, so quick crash course on what we did last time, okay? So this is pretty much f bracket g bracket x. Do you know what this is?
Is that just x, or you sub in like 2x plus 1 into x
Yeah.
squared minus 2?
Yes. So you can either do this. So you can either do what you did. So we're putting 2x plus 1 inside f, right? Or we can do we're putting gx inside f. So we put gx first. So gx squared minus 2. And both of you will give you the same answer, which is 2x plus 1 and then squared minus 2. Make sense?
Is that, and then so that's like the final answer, like 4x squared plus.
Yes, you want to expand that. You want to prove it's the same. And in the exam, you literally have to write that out step by step so your teacher know you're proving it, not just chucking the answer. Okay? It says show, so you want to show all the working. Oh my god, I was kneeling on the ground. My knees are dying.
Are we just doing A and B?
Yes, that's all the questions. That's just part two. I screenshot it so I have more space to write it. So A involves what we call composite functions. And Hannah, you are really familiar with that, right?
Yeah.
Okay, I don't need to explain it then. B is interesting. B is not hard, but you need to know the concept. You need to know what the question is asking for. All right. Ask me if there's any questions, okay?
Yeah.
Michael,
Yo,
I'm on like the last step and I like don't know what to do.
for B or A?
B.
Okay, so Hannah, have you done it yet?
Yeah.
Okay, should I make you explain or should I explain? Hannah, do you want to explain this?
Um, the last part for B.
Yeah, just like B throughout.
Oh, well,
Actually, yeah, go on.
I just did 4x squared plus 4x minus 1 equals x squared plus 5x plus 3. And then I did what we did before with the moving the equations over to equal 0. And then I did the factors of 4, which is 1 and 4, and then I did or 2 and 2, and then I figured out which 1 times 3 would equal -1.
Adriana, which step did you get up to?
Well, I got up to like that pop, but like I did like a pop like before the brackets like 3x squared minus 4x times 3x. What? Oh no, 3x squared minus 4x plus 3x minus 4x.
Oh my, how did you get to minus 4x plus 3x? How did you get there?
Cause I did 3 times -4 to find like the common, like, you know?
Send me a photo of your working. I'll have a look. That's very strange. All right, but anyway, while you're taking the photo, Adriana, did you get how I got to this step here?
What?
Do you understand how I got to this step here?
Yeah, I did that already.
Oh, and okay, so you were trying to factorize, right? So you
Yeah,
got this, right?
yeah.
Oh, okay. And then what you got?
And then, well, I sent the photo to you. And then I got 3x squared minus 4x plus 3x minus 4x. And then I
Oh,
put,
you're doing it that way. Okay, I see. So you're not one looking. If you're not one looking, okay, Hannah, this is something new. If you're not one looking, there's a way to do this. So you're essentially trying to predict what the root is, right? This is another way of trying to factorize quadratics that does not have a 1 as the coefficient of x squared. So I did this in high school as well. It's pretty useful. So you're trying to break up this minus 1x into its components. Knowing that we have a 4 here, it's probably maybe 4x and 3x, right? So let's just do it's 4 and 3, so it's a plus 4 minus 3. Oh, sorry, minus 4 plus 3. So we're essentially just trying to guess this. Hannah, does that make sense?
oh, I wrote it the wrong way.
Right, Hannah,
Wait,
Hannah, do you follow this?
Yeah, yeah.
So we broke this apart, hoping that we can factorize using this. So first of all, this part gives us, we can factorize 3x out easily, right? And this gives us x plus 1. Hannah, yes?
Mm-hmm.
This part we can factorize out minus 4, and the remaining gives us x minus 1, x plus 1. So yeah, so having the x plus 1 front in the front, we try to get another x plus 1, so that now we can treat the x plus 1 as a separate thing, and then take 3x minus 4 for the first factor. Okay, does this make sense?
Yeah. Oh, yeah, that's what I got. I just did it a
Yeah.
different way.
So see, yeah, this is another way. So see here we have x plus 1, x plus 1. We just treat x plus 1 as a separate object. We factorize it out, and then 3x minus 4 here. So 3x and 4 here goes to here. Okay? All right. I'm not gonna. Oh wait. I probably will do that. Okay. Solution is gonna be x equals 4 over 3. X equals minus 1. Same thing.
yeah.
All right.
Mm-hmm.
Good job, Adriana. Did you get it?
Yeah, I realized what I did
Okay.
wrong.
I'm not gonna look at the working then in that case. All right. So we had a look about. Okay. Before we move on to complete the square, is there anything you guys wanna? Any questions?
No.
All right, cool. So we only have 10 minutes, but we can do some completed square practice. Do 1, 2, 3, 4, 5, 6, please. And then I'll spend the last maybe 3 minutes going through the answers. If there's any questions, ask me, okay? I'll uh I'll break it into a new page. Wow. Oh, what the sorry for the lag. Okay. All right. Yeah. I'll give you guys like 3 minutes. Do as much as you can. 3 to 5 minutes. Okay.
Wait, Michael, I'm still a bit confused on how to do the completing the square.
So it's already moved to the second on the right, right? Remember when we did completing square, we always focus on the first two terms, right?
Mm-hmm.
So what to do with the first two terms? How do you complete the square here? It's x plus something squared. What's the something? It's 12 divided by 2. It's half of the second term, right? Right? But this term has something extra, so you're trying to find the difference and then make them the same by like subtracting that extra. Okay?
So wouldn't it be 12? Why?
Oh, okay. Expand this. What do you get? You can just verbally announce it to me.
X squared plus 12x plus 36.
All right, so for them to be the same, there's you must minus 36. So the last term is gone and you just have that, right?
So is that it?
So that's the left hand side, and then you replace it with this, and then it goes 2. Okay?
So that's it.
That's complete the square. Done. And then you solve this. Remember how to solve it? You just solve it casually. You don't have to do the factorizing anything. Just because since there's only one x, since x only appears once in that equation right now, we just solve it easily. Do you know how to do it?
No.
Okay. Why is
I don't
quadratics
get
so
this
tricky?
either.
Okay, why is okay, Adriana, do you get how I got to here?
I like forgot about completing the square.
Okay. So Hannah, you get how I got from the question to here, right?
Mm-hmm.
So once we complete the square, again, as I said, the point is to have x appearing once in the equation. So we can solve x by just undoing everything that's happening right now. First of all, maybe move 36 to the right, so we only have this on the left, right?
Right.
Yes, Adriana?
Yeah.
Okay, we'll worry about how to get from here to here later. Let me just tell you how to solve this. How do you undo the next step? How do you undo the square? Anyone?
Like you expand it.
No,
Oh.
you square root. Expanding will get you more x in the equation, and you are screwed if you're expanding. Adriana, not Adriana, Hannah, do you get this?
Yeah.
So again, since you are square, since the unknown square is 38, so the unknown is plus or minus square root of 38. I've mentioned this so many times. You guys know why, right?
Yeah.
Yeah.
And lastly, we move the 6 to the right, so it's minus 6. We tend to write minus 6 in front of the plus or minus. This is a habit. I don't know why. We like to write the plus or minus after that, but it doesn't really matter. Even if you might write minus 6 after plus minus, fine. Yeah, that's the solution. So that represents for two solutions. That stands for two things. Okay, minus 6 plus square root 38. Again, because we cannot work out the value of square root 38 on the spot, we like to just write. We just like to keep it this way. But there's a corresponding decimal to it. Square root 38. What is it? Like 7, 6, like 6, approximately 6. So 6 plus 6, approximately 12. 6 minus 6, approximately 0. That's the solution for the quadratics. Okay. Hannah, you got it?
Yeah.
All right. We don't have time for more practice in this case. I think I'll leave this as homework. If you guys don't get it, ask me questions anytime on WeChat. And in the remaining 4 minutes, I'll explain to Adriana how we got from there to there again. Okay. Adriana,
Yeah.
First of all, expand x plus 6 squared. Verbally tell me what is this?
X squared plus 12x plus 36.
Oh, sweet. Okay. So yeah, if you know that, then this is x squared plus 12x. The only difference 36. We want to have this, so we must subtract the 36. Okay.
Okay.
So that now they are equal. So this and this are the same. Okay. And the point, and you may be wondering, like, how do we know it's plus 6, right? Where do we get this from? This is the general form you're looking for. And the tip here is that, wait, 1 second. The tip here is that this number is half of the x term coefficient, okay?
Wait, then what about the number 2? Like what about 3x?
What? Number 2. Okay, what do you think it is?
Like x plus, well, I don't know, actually.
It's half of what?
Is just 1 point, wait, half?
Yes, 1.5, yes. So it's x, what?
X plus 1.5.
Technically x plus negative 1.5 because there's a negative sign.
Oh, x plus x
Yeah.
minus 1.5 squared.
And when you expand this, if you expand this, what do you get?
X squared minus 3x uh minus
Plus
plus
1.5 squared. Okay, you don't have to work it out.
right.
It's 2.25. You should know that anyway. So the extra 2.25, you need to get rid of it. So just subtract this. Okay. Yeah.
Yeah.
And the square is completed. And these two
I get
terms,
it.
they are constant terms. Do whatever with them you want. Normally we combine them. Okay. Normally we combine them after we complete the square. Put it on the right or left. Doesn't matter. Okay. If we want to find the vertex form, right, we put it on the left. Remember?
Yeah.
So yeah, maybe Hannah listen to this as well. If we put on the left, what do we get? We get x minus 1.5 squared minus this is 2.25 and 2, so it's 4.25. If we have y, if this is a graph, then this would be the vertex. Okay, this 1.5 and negative, so negative 1.5. That's x minus, so that's positive, and then negative. This will be the vertex. Okay.
Okay.
So this is the vertex form. We get the vertex form by factorizing as negative 2, something like this. Okay.
Okay.
So the vertex is 1.5. Okay. Remember x minus, the minus part is always the opposite. So it's positive 1.5. And this is minus 4.25. Okay.
Mm-hmm.
Hannah, does this make sense?
Yeah.
All right, homework will be completing this last page. Okay, I'll send this screenshot in the group chat right now. My Zoom, not my Zoom, my Word document is lagging so much. I'll send it in the screenshot right now, and then I'll send a class note later when I get back to Sydney tomorrow. Okay.
Okay.
If there's any questions, you can ask me. Okay.
Thank you. Bye.
All right. See ya.
Bye.